with us from Volvo Cars. And then also we are working together then with Chalmers. And then moving into to paint up the background to this project, then many of my colleagues within RISE Mobility and Systems are thinking about things like this. We're talking about control towers in order to control global logistic chains. We're talking about autonomous transports, or using artificial intelligence in order to be able to handle the challenges in the global supply chain. And then, of course, we have electrification. But all these different tools, methods, and concepts are built on the assumption that physical transports are physical. What if this would be possible, that transportation could be digitalized? And then, of course, someone would say that this is science fiction. But if you look into the history, you can see that there are many examples of global physical logistics systems that has been transformed. And here we have one example where on the left side you see a person writing a mail, and then that initiate a very big global logistics systems, which ends up then in that the person receives this message. And then, as you know, the email came, and what happened with this global system was that it disappeared. A similar thing we can see within the record industry, where today Spotify has completely transformed that whole industrial system that was built up around producing and distributing records. So then how does that relate to AM then? AM, of course, has been around for decades. And then what is really interesting right now is that it's moving away then from being a tool for prototyping into mass production. And then, of course, this raises an interesting question, how then AM is going to influence these global supply systems that we have. Because as we saw in the previous presentation, you can locate the production in different positions in the system. So in SPARSAM, we're working then with the idea of where do you put the production and what consequences does it have to this system? And around that then, we are using different types of scenarios. So in the first scenario, you locate the production of AM in a central factory, which then of course means that you might need to ship it to a central distribution center. And there we have the scenario 2, because you could also position the production in a center, the distribution center, or you can push it even further out to a regional distribution center, or as was being discussed in the previous presentation, you could push it very close to the point of use or the point of consumption. And then, of course, as also was mentioning then here in previous presentation, then you can reuse materials, or you can use virgin materials, or you can also work with remanufacturing. So the questions that we are trying to look at in this activity is then, okay, which parts should be 3D printed, and where should they preferably be printed in this system? So usually when parts are being selected for AM, traditionally technical selection criteria has been used. For example, complexity of shape, or material cost, or that low weight is essentials, or you have a potential to consolidate parts, or there are small series. But then if you broaden the scope and then looking it not only from a technical perspective, but include other aspects into the equation, the end result might look different. One example then, what happens if you add the business perspective when selecting a part is that usually then when you calculate the cost on a part, you also calculate on a volume. And then let's assume that you are calculating on a volume that is 10 times bigger than you actually need. Then if you compare it to a IAM part, then it could be produced, or you could become then 10 times more expensive than compared to a conventionally produced part. So in many cases, the volume that is being produced is bigger than is being used, which means then, of course, that you need to put it into warehouses. And then when you put it into warehouses, you also need then to pay the cost for transporting these goods, and then also to carry the inventory. So the point here with the SPARSAM project is to broaden the perspective when you're making this calculation on what is worth 3D printing. And then, of course, we are going to keep the technical selection criteria. But then the idea is that we extend it with business selection criteria, like what kind of reductions can you make in warehouse cost or in inventory cost, or what if you increase the parts availability or calculate into lead time, or what are the numbers for reduced transportation, or from a customer perspective, it might be that you get a better uptime. And then also, as we saw in previous presentation, you can add a sustainability or a planet perspective on this, calculating in CO2 emissions or reductions in material consumption and then energy usage. Magnus, is there something that you would like to add on to this picture that we're painting up here?
No, I think that gives that covers what we have catched so far. So please, back to you, Markus.
Yeah. So the idea then is here to work with more selection criteria in order to take a broader perspective. So looking then, this is a feasibility study. We started off in October last year, and then we have been working for 2 months. The activity is divided into 4 different work packages, where we have completed the 2 first, where one of the first package is, of course, to establish the team, but then we have been looking into the current situation, what knowledge is out there, and what are the main interest in our industrial partners. Right now, we are shifting focus over then to this supply chain models and to identify the parameters related then to this topic. And then in the 4th work package, we are looking then for cases where we can drive the development of both the model, but also to start to quantify these different parameters and aspects. And this is thinking back to previous presentation. Then here we have a quite clear connection where the first presentation is a clear case. But then what we then would be able to add into such an activity would be a structure and then ways to quantify. Looking then at the team, as I was mentioning, we're dividing it into 4 different work packages, and then we have different competence and resources from our industrial partners covering then circular business model and supply chains, and then the additive manufacturing. And we also have, since we're talking about sustainability, it's not only then about the planet part, but also the people part. And here we have an expert then looking into the gender equality and so. So then, so far in this project, then, as I was mentioning in work package 2, we have been looking into the current situation, both into the literature, but also then among our industrial partners. And to give you a brief summary, then we're going to show a couple of slides, or what is in the literature here. And it's quite interesting to see also how the literature is reflecting the mindset evolution over time. Looking about 10-15 years back in time, here you see the scope of the thinking. At that time, it was very focused then on the factory, and then the methods and the main thinking was comparing conventional manufacturing with additive manufacturing, where additive manufacturing then was seen as just as another conventional manufacturing technique. So then, of course, if you would raise the question, okay, should we 3D print this part or not? What was done at that time then was to comparing a conventional manufacturing technique, production volume, or machine cost per hour, or labor cost, etc., and then compare it with additive manufacturing. And then at the bottom line here, you got a total cost per part. And everyone who has done this exercise knows that additive manufacturing usually come out short-handed in this comparison. Moving then a little bit forward in time, around 2015, the thinking has expanded. So when it comes to the part selection, a number of technical selection criteria had started to rise. Also, the design thinking has started to take a bigger room, meaning that if you can start to calculate the part consolidation or a reduction in materials, you get a different equation. Visiting then our industrial partners, Volvo Cars, Volvo Trucks, and Alfa Laval, all of them had been a part of previous activities with this mindset, where then you can see here is an example from an Excel sheet where material cost, part complexity, and post-processing was included in the equation. Then the scope has expanded over time. Here we can see a very elegant work from 2018. And what they have done there is that they had looked at the complete chain from factory to usage. And then they have been using quite advanced mathematics in order to be able to, with this math, calculate which products or components should be 3D printed or not. But if you start to look at an equation like this, then what we have seen is that it has been very, very difficult to use this kind of math in real life and in practice. So even though that this work is very, very elegant from an academic perspective, then what we have seen is that it has challenges when it comes to its practical use. And coming then to practical use, one work that we have found that has been very, very interesting is a work that has been done within Volvo Trucks. And here they did a degree project together with Chalmers. So what they did was they called it the supply cost analysis, and then they were looking at additive manufacturing of slow-moving parts. And the interesting thing in this work is that then they have taken a broader perspective, and they have been identifying in a fairly simple model. They have been looking at production, inbound transport, warehousing, outbound transport, and then touching upon the usage part, where, for example, including cost for a vehicle off-road. Much of this model is highly cost-focused. So in this model then, the answer to should we 3D print this part, yes or no, then they are having a broad perspective, but then primarily looking at what are the transport costs, what are the warehousing costs, what are the costs for not being able to provide a part to a customer. But in our work then together with, we have seen that this is a very, very good starting point, especially since it has been growing out from a very practical oriented thinking that, okay, we have thousands of parts and we need to be able to select which of these thousands parts we should 3D print, and then they have been taking a broader perspective. Of course, me and Magnus, we asked them, Volvo Trucks, why are you interested in SPARSAM? I mean, you already have the model. And the answer from Volvo Trucks here was that, well, this is good, but it's not good enough. We need more. Okay, so what do you need? Well, in this model, it has been focused on one of the scenarios that we were talking about. In this case, the scenario was focused on placing the production in a central distribution center. The main reason for that is one relating to the question that I was asking to Robin earlier, that it is a cost associated with pushing out the production closer to the customer. So therefore, they had to choose a scenario. But then also they were interested in adding the sustainability dimension into this. So this is then the background, and then the challenge for the SPARSAM project is that we are then looking at a selection model that has become very, very broad. And now I'm showing you very much work in progress. So it's very, very sketchy, but it indicates our thinking and where we are right now. So here in the center, you see the cost-focused model that we have been picking up from Volvo Trucks. But in dialogue with Volvo Cars, we have seen that we need to extend it to also include the R&D dimensions. We also need to extend it into the use phase and to the end of line in order to be able to capture the sustainability aspects. And if we're talking about sustainability, then of course the material dimension becomes really, really crucial. Are we using recycled materials or are we using virgin materials? And then of course you can also start to think about, okay, perhaps we also can start to talk about remanufacturing. So here we have then a model and a thinking. And out of that, then we have started to boil it down, where we look at it from a activity perspective, where we have looking at from the life cycle. We have the design phase and all the different phases in the life cycle. And of course, you can break this down into different type of activities. These activities are then influenced by which scenario you are using. If we're having a scenario 5 here, then very close to the customer, then of course you can decrease the number of transports. And if you add or remove activities in the life cycle, that of course has an implication. And that implication, or as we were talking about earlier, the arguments, it could be expressed in time, you save time, or you save costs, or you get the sustainability saving. And talking then about sustainability, you can look, as we have seen earlier today here, at CO2 equivalents. Of course, you can see reductions or increase in material consumption, but you can also see energy usage. And so with this model, then we see that we can then on a high level, but then also by adding more detailed activities, have different resolutions. The resolution you see here is extremely high, but then if you would start to describe a supply chain based on one of these different scenarios, then you could also start to describe it in time, cost, and sustainability dimensions. So what we are then aiming to look at in step 2 is that what we want to do is to identify a current supply chain. Most likely it will be a conventional supply chain with material virgin supply into tiers, into a factory, with a boat on 22 days on the sea, with a regional distribution center, and then measure, okay, so how much time does that take today? And then compare it with one of these different scenarios. It could be a factory scenario. It could be the central distribution scenario, or it could be pushed very far out, close to the customer. And then with this model, then, of course, you need to detail and define the supply chain or these different activities, but then we could compare. So if this is the traditional way of doing it, and now we have designed the supply chain like this, then what savings or gains are we getting from a time, cost, or sustainability perspective? And out of that, then we get different types of values. And as you can see, this thinking that we are discussing here can be applied on many, many different cases. So to us, we are more than in step 2 looking for different cases to apply this framework, to challenge the model, to verify it, and of course then to develop it. So I guess that was the presentation of SPARSAM and the thinking and what we are looking for in step 2.
Yes, and Markus, we can maybe add that we, from the visits of the companies, the partners in the project, the Volvo Cars, AB Volvo Group, and Alfa Laval, we can see how serious the partners are working with this selection process, and come far in this, not only thinking, it's only doing in these processes. But we also see the tricky thing to select components. And we also see that what we are aiming in this project about sustainability parameters, they needs to be added. We see one of the partners has add a kind of relationship between saved CO2 and an amount of money in the process. So this is going on within the companies because the corporate goals from the board and from the direction is to be really CO2 neutral. So this is an important part of the development process forward. And we are searching for a research project, and in the research agenda, we can see that there will come interesting tools, virtual tools for designing for AM to reduce support structures. That will also mean that you can improve the circularity percentage of powder and reduce post-treatment and waste. And you can control the 3D printers in a better way. So there are also research topics related to the AM Center's research questions and resources in that area.
Mm.
So thank you.
Mm.